Okay, so we continue from, or let me just say, we continue with summarizing the JK flip-flop. I introduced this as a modification of the RS flip-flop to eliminate the illegality condition, the illegal condition in the RS flip-flop. How do we eliminate it? We have feedback being input on our flip-flop. So we have J, K, and this is the flip diagram. Here we have our Q and our Q bar. Here we have our clock. This is our JK flip-flop. Two inputs, J and K, two outputs, Q and Q bar. We have an interesting additional feature called the toggle from the RS flip-flop. We now have the toggle. J is equal to K is equal to 1. Everything else remains the same. J is equal to 0. It's the same as S is equal to 0. Reset with the set condition, set state, reset state, memory state, and an additional toggle state. Everything else remains the same. The truth table, the characteristics table, characteristic equation, excitation table, we summed everything up. We continue. When I talked of the JK, I introduced the race condition. What exactly is this? What exactly is the race condition? The race condition is when for J is equals to K is equals to 1, we have the toggle effect, but in a continuous manner. In a continuous manner. The rest condition is sort of a toggle effect in a continuous manner. The toggle effect on its own is not a problem, but if it happens continuously, then we have an issue. This can be demonstrated by a clock. This can be clearly demonstrated using a clock. Right, we have our clock. Right, this is our clock, 0, 1. Then we have our J, which is equal to 1. Let's say this is our J equal to 1. Yeah. Let's say this is my J equal to 1. 1. Then my K is also equal to 1. This is 0. This is 1. Then what happens to my Q plus? If I have J is equals to K is equals to 1, my Q plus will be the toggle. But if the duration of the clock, this duration, this is my period T. If the, nope, this is not my period. If this duration of the clock, let me put it here. Let's say my clock is level triggered. It means there is a change of state here. Let me begin with this. My clock is level triggered. There is a change of state here. There's a change of state here, etc., etc. If the duration of the clock where there is need to change state is far greater than the delay of the JK flip-flop. When I talk of the delay, let me introduce delay of JK. If I input something here, J and K, whatever happens with the nuns here, with the nuns here, it takes time. It takes time to get an output. That is called the delay of a flip-flop. It doesn't happen instantly. If I have two inputs, A and B, to get an output Q, it does not happen instantly. It takes a little time. That time is called the delay of, in this case, of the logic gate. In this case, we have delay of the flip-flop. If that delay, time taken to get an output, is far much less than the time we have here, TD. What that means is, when the clock is 0, J is equals to 1 here. When the clock is 0, we have the memory state. Let's say my Q was 0 then. It means my Q remains 0 here, the memory state. But what happens when a change is triggered by the clock? What happens when the change is triggered? We have the toggle state. I go from 0 to 1. But if my delay is far much less than the time TD, what happens is I have an output 1 here. Then the toggle effect takes again. I go back to 0, toggle effect again, 0, toggle again, toggle again, toggle again, again, until my triggering is done. This is what we call toggling continuously. Why are we toggling continuously? Because the delay, the time to get an output, what happens with my JK? As soon as I get an output here, Q is equals to 0, it is being fed back here. When Q is equals to 0, my inputs are equal to 1 and 1, J and K. Let me do this. I have J, K, Q, Q bar. So I'm saying my J is equals to 1, K is equals to 1. This is toggling. Soon as I get an output, starting with Q is equals to 0, it is fed back here. When it is fed back, because of this toggling, my next output will be 1. It is fed back because of toggling, my next output will be 0, fed back 0, 1, 0, 1. Now, if the time of delay is far much less, it means I have 0 1s, 0 1s until I'm at this point. Then if I'm at this point, in this case, it happens when I'm at a 1, my clock is equals to 0, I have the memory state. Then when the level triggering happens again, I have the toggling again, 0, 1, 0, 1, 0, 1, 0, 1, memory, 0, 1, 0, 1, etc., etc. This is not required. We only require toggling. This is what we call the rest condition. Toggling continuously. We don't need this. Rest condition. We don't need this. What we need is toggling. This is the rest condition. What we need is toggling. What we need is a case where if we have proper triggering, I go from 0 to 1, right? From 0 to 1 here. Now when the clock is 0, I have memory. It means my 1 stays. When there is a trigger again, I go from 1 to 0, toggle. 0 clock memory. When there is a trigger again here, I go from 0 to 1, toggling. Then I have, when clock is 0, I have memory. This is the proper toggling we want. But if that delay is so much less than this, then we have the rest condition, which is what we don't want. How do we remove the rest condition? We have many ways. The most common way is to not use this level triggering. What is the other type of triggering we have? We discussed the methods of triggering participation. We have level triggering, and what else?
Edge.
We also have edge triggering. Now, if I remove level triggering and I have edge triggering, it means change of state is only happening here. And tell me how much time is that? Close to 0, believe me. Change of state is only happening here. This is positive, positive, positive. Now, what I have is edge triggering. Instead of level triggering, I now have edge triggering. So what happens? I start with a 0. What will be my Q next? There is a toggle here because of that edge triggering. What happens here? The toggle remains because there is no change of state here. When I go to 0, the toggle remains because clock is close to 0 here. We have the memory state. Then when I go to the edge, we have the trigger again. The trigger again will go from 0, will go from 1 to 0. We go back from 1 to 0. The toggle. Then during this phase, no change of state. State only changes on the edge. So my 0 remains until I'm here. Then I have my clock. It goes to 0. Memory state. It remains positive trigger, toggle. And it goes toggle, memory. Perfect toggling. One way of removing the rest condition is not using level triggering. Instead, use edge triggering. This is why most clocks are edge triggered. This is to avoid exactly that. Another way is using what we call the master and slave. Another way is using the master and slave. And with that, I introduced the master and slave JK. All right. We can eliminate the resting condition by introducing the slave. We introduce the slave, what we call the slave. What is the slave? This is just a copy of the master, which is a copy of the master. You see how that works. We introduce a slave, which is the copy of the master. Now there is a change on the clock, however. The clock is complemented. The clock is complemented for the slave. So basically, this is what happens. We have my JK. J, my clock, triggered edge. We have my K. We have my output. Let's say this is my Q master output. We have my Q bar master. We add another JK, which is now the slave. The inputs of this JK are my outputs of the first JK. Here I have Q, I have Q bar. What happens to the clock here? The clock is complemented. So what we have, the clock is complemented. So this is my master, and this is my slave. Q output is then fed back here. Right. Key features here to note is this complement. It means when the clock is 1 here on the master, the clock is 0 on the slave. That is the key feature. When the clock is 1 on the master, it is 0 on the slave, and vice versa. What does this help? When the clock is 1 here, the master operates normally as a JK. But what happens to the slave? The slave is in its memory state. And vice versa. When the slave is operational, 1, the master is in its memory state. Perfect demonstration using the clock again. Can I use the same clock? I think so. Right. We'll use this same clock. This is my clock. I know J and K are equal to 1. What happens to Q next? If I'm using the slave. Okay, I know J and K are equal to 1. What happens to my Q next? Now I have my Q, M, and my Q output, where QM is the output of this output of the first JK, the master. Then my Q is the output of the whole system, which is also the output of the slave. This is what happens. Right. For QM, let's say my present input is 0. What happens when the clock is equals to 1 for QM? Here I have my clock is equals to 1. When the clock is equals to 1, I know J is equals to 1, K is equals to 1. When the clock is equals to 1, I have the toggle effect. There I have the toggle effect. When clock is equals to 0, hold memory. Toggle again when clock is equals to 1. Then I have hold, toggle, hold, toggle, hold. This is my Q, M. What happens to the overall Q, the output? When the clock is equals to 0, let's say I started at 0 here. Let's say I started at 0. Okay, let me say this 0. When the clock goes to 1, my clock for Q is goes to 0 because it is complemented. Here, clock is goes to 1. Here, the clock is goes to 0. It is complemented. So what happens? My clock is goes to 1 at this stage. Here I have the hold because the clock is goes to 0. Now, when the clock changes to 0 in this case, that is where I have my toggle here. Clock is goes to 1, I hold. Clock is goes to 0, toggle, hold, toggle, hold, toggle, hold. The key is the complement on the clock. The key is the complement on the clock. Now, instead of having the racing effect, it will not happen because of that complement. You see the overall output, we will have no race condition. Ways of eliminating the race condition. We have the edge triggering, we have the master slave. Why do we have the master slave? Is to remove the race condition. How is it removed? This is the key. It is removed by complementing the clock for the master and the slave. Everything else remains the same. All right, questions on the master and slave. Questions on the master and slave or comments? Nope.
Sir,
Yes.
could you please go back to the diagram that has the QM when we're drawing the graph, like
Graph.
that one with the highs and lows?
Yes.
Please, could you please explain the QM for me? I just got a bit lost.
The QM is this output. It's this output here. The first output. We have an output here. This is QM. We have another output here, Q, which is the output of the whole system. So the master and slave is like this. This is the whole system right here. Right? But we want to see how does it function. We have an intermediate Q here, which is the QM inside the circuit. Then we have the output Q outside the circuit of the slave. Coincidentally, it is the same as that of the slave. So we wanted to find what is the output Q for the master. The output Q for the master is like this. When the clock is 1, that is when we have the toggle. Because the clock is connected to the master. As you can see, there's a clock here, which is connected to the master. So when the clock is 1 here, we have the toggling effect on QM. But when clock is 1 here, we have 0 here. The clock is 0 here. We have the memory state for Q. Sort of vice versa. When the clock is 0 here is the memory state. The other way is the toggle. So back to the graph. We started with a 0. When the clock is 1, we have the toggle. When the clock is 0, memory. 1, toggle. 0, memory. 1, toggle. 0, memory. Toggle, memory. What has happened? Why we no longer have the racing condition? One can pause. Why don't we have the racing condition here? It's because we increased the delay. Let me put it out this way. We increase the delay. Instead of having the delay being of only 1 JK, we now have 2 JKs. 2 times delays. When I started explaining the race condition, I said it can be a case where this level triggering, the delay is far much less. The delay of your JK is very less, far much less than this time here. But what happens if we introduce another JK, the slave? It means we've increased the delay. With increase in the delay, it means probably we're approaching the same time. Now, the change of state is no longer like this because of the delay is much, much longer. That's why we have something like this, toggling. And the output is also toggling at the same time. I've said a lot of things. I'm not sure if I've responded to the question, but I'm hoping I did, because I mentioned a lot of things here. I pose a question, are you answered or not? Who had asked the question? She's no longer there. Anyone else with a question or with a comment? Master and slave.
Say,
Yes.
hatatanyakunzisa vamagumira munzira.
Ndagumira munzira papi.
Pamamadzoka apa mati sedelota apa tatakunyakunzwisisa man.
I've said a lot. You could explain as I want. This is the master, this is the slave. Well, let us just summarize this. I introduce the race condition. All right.
Yes.
I introduced the race condition. And I said it is because we have this time here of the clock being too much. This can be a less than a second. Let's say this is 1/10 of a second. But the delay, if I input something here, the moment I get an output here, it can be 100 of a second. So it means if my J is equals to 1, my K is equals to 1, every time I get an output, 110th of a second, there is a toggle. Another 110th of a second, a toggle, until I reach 1/10 of a second. So let me put this 0.01. This is 1/10 is 0.01. This is 0.1 seconds. And put it out like this. This is 0.01 seconds. So it means every 0.101 second, I have an output which is being fed back. Soon as it is fed back, there is a toggle. Fed back toggle. So here I probably have like 10 inside this 1 second. 10 togglings which are happening. How do I change that? I said one way is introducing edge triggering. With edge triggering, now instead of having the change over 0.1 seconds, we only have the change over this period, which is close to 0 seconds, really, this period. So now there is the toggle. During the 0.1 seconds, we no longer have change of state. Change of state is only on the triggering. Then we have proper toggling without the race condition. Another way, we have the master and slave. What happens with the master and slave? One JK, another JK, Q, Q. There's something that happens to the clock. The clock is complemented. This is my clock. Inputs J and K. Here I have QM and QM bar. Right. Instead of, let me say this, instead of using positive age triggering, we can as well reduce this time. Okay. Watch. Right. We had the resting condition times 10 here. Right. What happens if I reduce this time 0.1 seconds to 0.01 seconds? It means I no longer have the rest condition. It means when the output of my JK at 0.01 seconds counts, I have this. I have the toggling during that 0.01 second. This time, almost the same as this one. Or what happens if you're just playing with the numbers here? This remains 0.01. But what happens if I insert, let's say, another JK with another delay 0.09 seconds? Let's say the slave has a delay of 0.09 seconds. It means this time is no longer far much less than this one. It's almost the same. If it's almost the same now, it means even if the change is happening here, it will be equal to the delay. You will not have multiple outputs here. You will only have, during 0.1 seconds, you will only have one output. You will only have one output instead of multiple. So the master and slave is just one way of probably increasing the delay. And now with the use of this complement of the clock, the delay is increased by that hold, the memory state. Whilst the JK, this QM, you have an output, it is not directly being fed here. You have the hold state. It goes into hold because here 1, here is 0. It goes into hold. When it goes into hold, you are increasing the delay. Then when it goes to output, probably you now have total delay being equal to the time where you need to change your state there. I'll probably end up confusing myself. But this is what the master and slave is, ladies and gentlemen. Any more questions, any more comments? 2 minutes, I think we are done. Questions and comments.
Thank you, sir. Right.
Do a bit more research.
Right.
Monyatso verify with the because I've seen but just because I'm Zivi, you think it's correct, it's correct. No, it's not supposed to be like that. I've seen this because this is my first year doing this logic design. Next year, I'll probably be correcting a lot of things. I do a very good job at explaining things I don't even know most of the times. So do a bit of research on your own. Feel free to correct me. I'm never always all right. We are all learning. Thank you very much. I think we are done.
Sir.
Yes.
Are we going to do the master? There are 2 master slave flip-flops, right? The JK and the D1. Are we going to do the D1 or it's just the JK?
No. The logic remains the same for the D and the JK. I think I only had the JK prepared. I think this is the
All right,
complicated
okay,
one.
thank you.
This is the most complicated one. I think the logic, I'm hoping the logic behind the master and the slave concept remains the same. Okay, have a very good afternoon. I'm out.